A very good morning, good afternoon and good evening to all. This is Suvendu Sir, your physics mentor. Welcome to my YouTube channel. And in today's class, we will discuss the physics question that is available in section D of class 10 CBSE sample paper 2024 and 25. So, section D starts from question number 36. So, in this question, the figure is given. It is mentioned the above circuit is a part of an electrical device. Use the information given in the question to calculate the following. First, it is asking potential difference across R2. Okay. Now see the diagram. In this diagram, 4 ohm and R2 both are in parallel with respect to each other. That means we know in parallel combination potential difference remains same. That means potential difference across 4 ohm resistors, that is equals to potential difference across R2. So now find what is the potential difference across 4 ohm. So V is equal to current into resistance. So 1.5 into 4, that is your 6 volt. That means potential difference across R2, that is your 6 volt. Yes. So it is asking potential difference across R2. So our answer is potential difference across R2 is equal to 6 volt. This is your first bit answer. Next, in second bit, it is asking value of the resistance R2. Okay. So in order to calculate the value of resistance R2, so R2 is equals to resistance equal to voltage by current. So voltage across R2 divided by current through R2. So voltage across R2 is 6 volt. Now you have to find current across R2. So how to calculate? Now see the figure properly. Here in this path 2 ampere current is coming to this junction. So 2 ampere current is coming to this junction. At this junction point, this 2 ampere current gets divided into two paths. So in one path 1.5 ampere current is flowing. That means in other path remaining amount of current will flow. That means remaining amount of current is total current minus 1.5 ampere, that is your 0.5 ampere. Okay. So through R2 amount of current flows, that is your 0.5 ampere. Now easily we can calculate the resistance R2 value. So 6 by current through R2 is 0.5 ampere. So if you will solve 6 by 12, 6 by 1 by 2, that is your 12 ohm. So the value of resistor R2 is 12 ohm. So this is our second bit answer. Next it is asking value of resistance R1. Yes, it is very important. Now see how to calculate the value of resistance R1. Again, all of you observe this figure properly. Yes. So in third bit, in order to calculate the resistance R1, so resistance formula is voltage, resistance R1 equal to voltage across R1 divided by current through R1. So our main aim is to calculate what is the voltage across R1. So observe this circuit properly. There are three things. Let name the combination of 4 ohm and R2 as X. Let this is your X ohm. So if you will draw the diagram again, this is our R1. Okay. Now clearly mention these two things. One resistor is our 4 ohm resistor. Another is our R2 value. Already we have discussed. R2 value is 12 ohm. Yes. And here in the figure another resistor is given, 2 ohm resistor. 2 ohm resistor. Okay. So now potential difference across these 2 points X and Y we have already calculated. That is your 6 volt. So you mention it. The potential difference is 6 volt. That means out of the total voltage, your total voltage in the given question is 12 volt. Total voltage is 12 volt. This is your total voltage. So out of the total voltage, 6 volt is consumed by the combination of 4 ohm and 12 ohm resistor. Yes. So another thing, through this 2 ohm resistor, it is given 2 ampere current is flowing. That means potential difference or voltage consumed by these 2 ohm resistors, this is your current into resistance, that is your 4 volt. So out of the total 12 volt voltage, 6 volt is consumed by the combination of 4 ohm and 12 ohm, and 4 volt is consumed by these 2 ohm resistors. Yes. So potential difference across R1, that is equal to remaining potential difference is potential difference across R1 total minus consumed voltage. One is your 6 volt, another one is 4 volt. That means 12 minus 10, that is 2 volt. So potential difference across R1 is 2 volt. Another thing, in order to calculate the resistance R1, we have already discussed what is the voltage across R1, that is our 2 volt. So you write 2 volt divided by current through R1. What is the current through R1? Now you see the total amount of current is given in this question, that is coming towards that junction is 2 ohm. That means through the R1, according to question, 2 ampere current is flowing. So current value is 2 ampere. Now resistance R1 value is 1 ohm. So this is our answer. So next come to our question. Another question is given, that is from electricity also. This is one of the important question. Now you see, it is mentioned as shown in the figure above, A and B are 2 lamps and lamp A is rated at 12 volt. Lamp A is rated at 12 volt, 24 watt. Lamp B is rated at 6 volt. So let's wait. Yes, now we can discuss the whole question in a very comfortable manner with this diagram. So it is mentioned lamp A is rated at 12 volt, 24 watt. This is 12 volt, 24 watt, and also it is given lamp B is rated at 6 volt. Lamp B, it is rated at 6 volt. Again, when lamp B operates at its rated voltage, the current in it is 3 ampere. Okay, current through lamp B is 3 ampere as per the given data. Then the values of R1 and R2 are chosen so that both lamps operate at their rated voltages. So based on the information given in the above paragraph, answer the following question. First, it is asking calculate the current in lamp A. Okay, current in lamp A. In order to calculate the current in lamp A, now all of you see, in case of lamp A, everything is given. First bit question. In case of lamp A, it is mentioned its voltage rating and power rating. Now we can calculate the current through lamp A. So we know power equal to V into I, voltage into current. That means current equal to I equal to P by V. So 24 by 12, that is your 2 ampere. So this is the answer of your first bit question. So current through lamp A is 2 ampere. Now mention it, 2 ampere. Yes. Next it is asking state and give reason for the reading of the voltmeter. Yes. So now all of you see, both A and B, both lamp A and B are in parallel. That means in parallel connection we know voltage potential difference remains same. That means in for second bit we can write both A and B are in parallel. In parallel connection, potential difference V remains same. That means reading of voltage or voltage reading is equals to 12 volt. Yes, how it is 12 volt? Now see, lamp A is operated on 12 volt. Yes, it is mentioned in this question. That means across these 2 points, let these 2 points are X and Y. Yes, so when lamp A is operated at its rated voltage, that is 12 volt, current of 2 ampere is flowing through it. That means across X and Y, your potential difference is 12 volt. Similarly, across these 2 points, let it is P and Q. So across these 2 points P and Q, also the potential difference is 12 volt, because both lamp A and lamp B along with R2 both are in parallel with respect to each other. Okay, so always remember, here in this question diagram, don't think that lamp A and B are in parallel. Don't think like this. This is your lamp A. Another combination is your lamp B along with R2. Lamp B along with R2. Yes. So lamp A and the combined effect of lamp B and R2, these are in parallel. Yes. So it is asking state and give reason for the reading of the voltmeter. So voltmeter will show the reading 12 volt as per this given question. Yes. Then it is asking calculate the resistance of R2. Okay. It is very important. Calculate the resistance of R2. Now for third bit, come to the third bit. So in diagram, it is mentioned as lamp B and this is your resistor, that is your R2. And we have discussed these 2 points are P and Q. Let these 2 points are P and Q. Across this P and Q, the total potential difference is 12 volt. Yes. And also we have discussed what is the amount of current through this connection, that is your 3 ampere as per the given question. Okay, through lamp B 3 ampere current is flowing, and you see lamp B and resistor R both are in series, and in series connection your current remains same. That means through R the amount of current that is flowing, that is your 3 ampere. Across the resistor R, amount of current that is flowing is 3 ampere. Yes, it is clear to all of you. But what is our aim? According to third bit, it is asking calculate the resistance of R2. So now think how to calculate the resistance R2. Yes, that is our main problem. Okay, so see the given question. It is mentioned the values of R1 and R2 are chosen so that both lamps operated at their rated voltage, and in this figure we have mentioned what is the potential difference or what is the rated voltage of lamp B, that is your 6 volt. It is given. See it properly. Lamp B is rated at 6 volt. So that means for lamp B its potential difference is 6 volt. So what is the potential difference? That means as per the given question, the potential difference across lamp B. So across lamp B means across this potential difference is across these 2 points. The potential difference is 6 volt. Okay, but for the whole combination the potential difference is 12 volt. So the potential difference across resistor R, that is equals to total minus voltage consumed by the lamp B, that is 6. So remaining is 6 volt. Okay, so now potential difference across resistor R. See this diagram. Potential difference across R, that is your 6 volt, and current through the resistor R, that is your 3 ampere. As the lamp B and R both are in series, so current value remains same. Now we can calculate the value of resistance R. Okay, so for this given data, or for this case, what will be the value of resistance? So resistance is equals to voltage by current. Yes, potential difference is 6 volt, current is 3. That means the answer is 2 ohm. Okay, then this is our third bit question answer. Next, last it is asking find the value of resistance R1. Okay, what will be the value of resistance R1? Now think it properly. So as per the diagram, find the value of resistance R1. Okay, for fourth bit, again you simplify this whole concept as per this figure. So this is your resistor R1 having resistance R1. Now tell, in order to find the resistance R1, what we have to think? The voltage across R1 and the current flowing through the R1. So one more thing, you see the diagram. See this red color mark? Here total amount of current is coming towards this junction, and at the junction X, current starts to divide in two parts. So in one path 2 ampere current is flowing, and in another path your 3 ampere current is flowing. That means what is the total amount of current that is coming towards the junction X? That will be 2 plus 3, that is your 5 ampere. Yes, I incoming, that means I outgoing. That means this is your positive terminal and this is your negative terminal. Now we can say the total amount of current that is flowing through R1, that will be 5 ampere. Yes, okay. So as per the given figure, the current through R1 is 5 ampere. Yes. Now our aim is to calculate the potential difference across R1. Again, all of you observe this figure. What is the potential difference across R1? Yes. So see this figure. In this figure, if you will simplify this figure, this is your parallel connection. Okay. Take it as a single resistor. Let this resistance is your suppose Z ohm. Think it as Z ohm. Yes. So now you simplify the diagram as per the question. Here the total potential difference is 15 volt and Z ohm resistor is connected at this point, and R1 resistor is connected at this point. Now tell, out of the total voltage 15 volt, what is the potential difference or voltage consumed by Z ohm? Z ohm means always think about the whole combination. Yes, this is your Z ohm. Suppose. Now tell, what is the potential difference? That is your 12 volt. Already we have calculated, or it is given already. 12 volt. So potential difference consumed by Z ohm resistor, that is your 12 volt. So what is the potential difference across the R1? So across R1, potential difference is equals to total voltage minus consumed voltage, that is 12. That is your 3 volt. So now we can calculate the potential difference is our 3 volt, and current through R1 is 5 ampere. So resistance R1 equal to voltage across R1 by current through R1. Voltage across R1 is 3 and current through R1 is 5. That means this is your 0.6 ohm. So all of you remember, in this whole CBSE sample paper, this is one of the best question. Okay. So try to understand. Next, come to your Question for visually impaired students. This is also important. We have to discuss. Yes. So it is given, state the law and write the formula that connects the electric current flowing through a conductor and voltage applied across it. State the law and write the formula. Okay, all of you know this is a very simple question. The law is your Ohm's law. And it is asking write the statement. So what we have to write? The statement is when temperature and other physical conditions are constant, then current flowing through the conductor is directly proportional to the potential difference applied across its two ends. Okay, so as for Ohm's law, V is equals to IR. Yes. Next, it is given in a household 5 fans each of 100 watt are used for 4 hours and an electric press of 500 watt for 2 hours every day. So calculate the cost of using the fans and electric press for the 60 days if the cost of 1 unit of electrical energy is 6.5. Okay. First, you read the question properly. Next, we have to calculate. So, as per the bit 2, so in one day, first, all of you calculate what is the total power consumed. So, P total consumed in one day. It is given in one day 5 fans and an electric press. Okay. 5. So what is the total power consumed? Total power consumed is 5 fans of 5 or 4. Yes, 5 fans of 100 watt is used for 4 hours. Acha. Next. So 5 fans each of 100 watt are used for 4 hours daily and an electric press of 500 watt for 2 hours every day. So our aim is to calculate the in one day what is the total power consumed. That means total power consumed by 5 fans plus power consumed by electric press, one electric press. So total power of 5 fans is what? Number of fans into power of each fan, that is your 100, that is your 500 watt, and they are operated for 4 hours continuously in a day. That means total power consumed is total power consumed by, so power consumed by 5 fans, that is your 2000 watt. Again, in order to calculate the total power consumed in one day, you calculate the power consumed by the electric press. So power of electric press is given 500 watt and it is operated for 2 hours. So plus 500 watt into 2 hours, that is your 1000 watt hour. Yes, the unit is watt hour. So what is the total power consumed? That means total power consumed in one day is your 3000 watt hour. That means this is equal to 3000 by 1000 kilowatt hour. It is equals to 3 kilowatt hour. Solve it properly. Next, it is asking calculate the cost of using the fan and electric press for 60 days. That means if in one day the total power consumed is 3 kilowatt hour. So now calculate in 60 days the P total consumed, that will be 60 into 3 kilowatt hour equal to 180 kWh. 1 kilowatt hour is called 1 unit. So 180 kilowatt hour means 180 units. So as per the given question, cost of 1 unit of electrical energy is 6.5. So total cost now we can calculate. Thus total cost is equals to 180 into cost of 1 unit, that is 6.5 rupees. So if you will calculate, it will be 1170 rupees. This is your answer. Yes. Next come to the last question of section D. So it is asking, state Joule's law of heating and write its mathematical expression. Okay. So as per Joule's law of heating, amount of heat produced in a conductor is directly proportional to square of current flowing through it is directly proportional to resistance of the conductor and also amount of heat produced in a conductor is directly proportional to time for which current flows through the conductor. Yes. So this is the statement of Joule's law of heating, and its expression is H is equals to I square RT. Okay. Next, in bit 2, it is given two resistors of resistances 2 ohm and 4 ohm are connected in series and in parallel. So simply you draw the diagram. Two resistors are there, 2 ohm and 4 ohm. First they are in series, and in other case they are connected in parallel. Yes. So we know when they are in series, what is the R total, resistance total? That is your 2 plus 4, that is 6 ohm. And when they are in parallel, 1 by Rp is equals to 1 by 2 plus 1 by 6. So it is your 4 by 6, that is 2 by 3. So equivalent resistance is 3 by 2 ohm when they are in parallel. So according to question, compute the ratio of total quantity of heat produced in the combination in the two cases if the total voltage and time are kept same for both. Okay. So we have to calculate the ratio of heat produced. So according to given question, first they are in series, then in parallel. So we have to calculate heat produced during series connection to ratio of heat produced to during series connection to heat produced in parallel connection. Hs by Hp we have to calculate. So we know H is equals to I square RT equals to V square by R into T equals to VIT. So which formula will help us to solve this question? So in given question it is mentioned voltage and time are kept same. So if you will choose this one, H is equals to V square by R into T. So as for the question, voltage and time they remain same. That means we can mention they are kept same means they are constant. So H is equals to constant divided by R. So H is proportional to 1 by R. That means HS by HP is equals to RP by RS. Okay, so as H proportional to 1 by R as per the mentioned data, so HS by HP equal to RP by RS. So what is the value of RP? RP value is 3 by 2 and RS value is 6. So it will be 3 by 2 into 1 by 6. So when they are in parallel, 2 ohm and 6 ohm. Yes, 1 by RP, if you will solve 1 by 2 plus 1 by 6, the LCM is 6, 4 by 6, 2 by 3, that is 3 by 2. Yes, this is correct. And your RS value is what? 6 ohm. It is asking HS by HP, that is your RP by RS. So RP value is our 3 by 2. Yes, so where is the mistake? Yes, so it is given two resistors having resistances 2 ohm and 4 ohm. Yes, I have mentioned 6 ohm. So this is our wrong calculation. So when both the 2 ohm and 4 ohm resistors are in parallel, so what will be the equivalent resistance? 1 by RP is equals to 1 by 2 plus 1 by 4. So it will be, so LCM is 4. So 2 plus 1, that is 3 by 4. So your RP value is equals to 4 by 3 ohm. Yes. So now you put your RP value is 4 by 3 and the RS value is 6. That is equal to 4 by 3 into 1 by 6, that is 2 by 9. Okay, so HS is to HP is equals to 2 is to 9. Yes, so this is all about for today's class. So stay tuned for next update. In next class we will solve the section E part. Okay, thank you and have a nice day.